This is a real-time system. We should probably talk about a little bit more about how we're keeping our system safe and what's running, what's not, what threads we're using. So we've got a couple of event queues. We've got basically just the two. We're running a a sample once a second, sorry, and we're writing so that gets called every 1 second. We request for it to pull a sample every second. It's running on the highest priority thread. And then every 60 seconds, we call the SD card. And then, so for displaying to the terminal, writing out elec LEDs, that is all done in another thread to keep those threads short so they can run at a guaranteed once a second. We need to be shorter than that to obviously guarantee our processing rate. So here, that function is that pulls all the data. These are to get the requested data out. They're protected by mutex. We'll hop into that function, have a look in a sec. Just calling our terminal queue to display the data. We send that data to an LED parameter and we push that data to our mailbox. So we'll just hop into our output data function. And we will see we've got a lovely mutex in here just to protect our function. And obviously we will require a threshold check. So that runs, and we come down here to threshold check, just a nice little function. And it obviously tries to lock as well, because we don't want to, that's for when we're updating the parameters for threshold. We don't want to be changing those whilst we're trying to compare against them. Not ideal. So yeah, so we have a notify all here, which are change sense thresholds, upper and lower. And obviously it gets notified and it will unblock then from the waiting state, and we'll be able to change those parameters. Nice way to keep it safe. Continuing with that, that is also the same for the LED strip latch that we made, that we were talking about. It comes from our, where is it processed? In serial command, we have for returning the integer and the characters, we get notified in our main system. So we can go ahead and do that. That runs on its own thread. So obviously anywhere we've got something that we're waiting on, needs its own thread, or it needs a message queue or an event queue, sorry. Just to make sure we're always running, we're always doing something. We're not just sat there spinning or polling or just waiting. We've got this is a little interface for the micro SD. So we talked a bit about how it does the resets and how it's monitoring itself to look after itself. This is what it returns when it's ran. Just a good way to check that it's running properly. Good error proofing. As we saw, the system still ran without the SD card. So just to make sure it's running. Obviously not ideal because we want the samples, but it does still run. And then I'm not sure what else would be noteworthy to talk about. Obviously we've got we need a custom data library obviously to store all of this data. With each one needing its own parameters, I felt it was best suited to reuse the same class for each one. So if we have a look inside setup sensor, we will see our class and what it's doing, which is nice. So, and yeah, obviously we need to be protected by mutex. Whenever we've got this shared resource, it is mutex protected with timeouts. Nothing timeouts because the order of the program is very well sorted and we don't get any race conditions. As far as I'm aware, with a slew of testing, I will include the test data where I was running 4 or 5 hours yesterday, just filling up the SD card, just checking everything works, removing the SD card, just putting it in, just as many random things as I could think of to try lock up the system, and it seems to work absolutely fine. The only thing would be we haven't done yet would just be the full processing of the user input data. Unfortunately, I haven't quite had time for that, often the way it goes. But other than that, I feel like we have done everything else, everything we can possibly do to guarantee the safety of our system and fulfill the requirements